So let's take a look at interfaces, what they are, how we create them, and why we use them. So an interface is very similar to a class. It basically defines a contract what a class should have contained within it, including the methods, the properties, the indexes, and the events. They're the four things that an interface can define. And it basically forces any class implementing that interface that they have to implement those specific pieces of information. And that's why they often call it a contract. So what we'll do, we'll show you how to create an interface, some of the caveats involved in the interfaces, such as everything having to be public, then implementing it in a class and going through the uses and the ways we use the interfaces and why we use them, as well as some of the benefits. So let's get straight into it. So we'll start off by creating a console app in this case. That's fine. We're just going to show the interfaces being used. So we'll just start by creating an interface. And it's exactly the same as a class. You basically type the access modifier. In this case, it always has to be public. And then instead of typing class, you just type interface. And then you give it a name. And again, convention typically dictates you start the name with I. So we'd say I, my interface. And that's basically it. So instead of simply having public class, you'd have interface instead. Now, the thing with interfaces, as I mentioned, is they always have to be public. You define private and it'll simply complain. Because the point of an interface is to define something that other bits of code can consume. So naturally, you want it to be available to those bits of code. So it's always defined as public. You can leave it off, and instead of by default classes that go private by default, this interface would be public by default. But I always like to be explicit in what I define. So this is now defined as a public interface with a name. And then what you can have in these interfaces is four things. The most common is a method. So you can define a method. Now, if you're going to define a method just the same, you don't put public or private or anything else. You just ignore the access modifier, so you never put them in interfaces. Instead, you just type the return type. So let's just say void. And we'll just say this, do something. And to be honest, this is going to we're going to use this, so we want to really think of a real world example. So I'm going to change this to a logger. I'm going to say from I, my interface, to I, logger, we'll just call it. And then this would be, say, log message. And we pass in a string message. So in this way, the way we do this, instead of it being, say, a public void log message and you define a message in a class like this, you simply declare what the method signature is. So you don't provide a body to the method, you just put a semicolon, and you don't provide an access modifier, it's always public. But what this now says is that any class that wants to implement iLogger must have a method called log message, and it must be public. So if we were to then do a public class and call this console logger to implement this interface, to say that we honor this interface and we can be cast into this interface, just put a colon and then the interface name. And now you'll get a warning telling you you're not implementing that interface. So you can just press Control and dot and then enter to implement interface, and it will automatically add all the methods that we need. So you can see now this honors an iLogger, but it's also forcing us to do that. If we change the name, it would complain that we're not implementing this interface. If we change this to private, it'll similarly complain that we're not implementing the interface because it has to be public. So it forces the class to honor a very specific set of methods, properties, indexes, and events, but without having to, you don't have to know the specific type. So now let's say in here, how we'd consume that would be var logger equals, and as I mentioned, you can't just do like I new logger and create an interface. You can't create interfaces because they don't contain any definitions. So instead, you'd create typically a specific version. So you'd say, let's pick the console logger. And again, you wouldn't do this directly. You wouldn't just typically do this. This would usually come from dependency injection. And instead of this, you would have something like, you'd either inject it in the constructor here and just say iLogger logger, and now it's been injected for us by dependency injection. Or if you were using like a service locator type setup, you probably do di dot get service iLogger. and that would create and return whatever specific logger our application decided to construct and use. So it allows the top-end application at any point to change from, say, a console logger to a file logger, and the consuming code that just wants an iLogger doesn't have to change. So to simulate that without dependency injection, we could simply have, say, static iLogger get logger, and this wouldn't usually be right here. Obviously, this would be, say, simulating the application and where it's coming from. So then in here, we just for now return new console logger, just to show that, you know, that's where we get it. And now here you just say get logger, and this would be replaced with real DI. And this would just simulate getting an iLogger can't type, jeez. An iLogger from DI, and then that just returns a console logger for now. And then once we have the logger, you'll notice now it's an iLogger. It's not specifically a console logger. So this consuming part of our code has no idea that it's specifically a console logger, but it can just do logger.log message, say something, and we just say log it. So that would do that. Right now we don't implement it, so in the console logger, let's actually do it. Let's do console.writeLine message, and we could say console logger says, and then the message. And we log the message that way. A logger that writes to the console. A logger interface. So for now the comments are basic. Logs the specified message. So if we run this now and put a breakpoint here, this is now, we've gone through the entire how you'd physically use an interface. So you've just seen it firsthand how you'd consume it. So you can see now we've hit the breakpoint, we've got to there. In fact, we should just do, instead of breakpointing and it disappearing, we should just do console.readline. So we just have to press enter to exit. And then we should see it say, there you go, console logger say something. So it's up to the logger then to do what it wants, and our consuming application doesn't need to change. So if we took that a step further, say, and made a second logger, because this is usually the point of interfaces, is to allow your code to simply swap out implementations for different implementations. So this could be a logger that you want to log now to a remote server or to a file or somewhere else. Or when you're running in debug mode, you want it to log to the console, and when you're running in release, you want it to not log anywhere, so you just have a blank logger. Things like that. It could be a database server, and you could have just, you know, iDatabase Manager or some kind of interface that gives you the features you need. But then in the back end, you can swap it for an SQL database or a MySQL database, and the consuming code wouldn't have to change. So if we make another one, public class file logger, iLogger, just the same, and we implement it, and we say a logger that writes to a file. And in this case, because you'd really want to define, or you may want to define where the file logs, you could either have a custom constructor. So even though the logger generic one doesn't know a file path, when it's specific to, say, a type of logger, you're still perfectly within your rights, if you will, to create a new constructor. So we'll just say constructor, and then here you could say string log path, and you'd have here some private members, and you'd have private read only string log path, the path to log to, and then in here you would have the log path equals the log path passed in, And now you have your constructor that is specific to this implementation, that the consumer also doesn't care about. So the consumer being our class here, we don't have to say where the path is because it shouldn't be a concern of this class. It just wants to be given a logger. And now in the logger here, we can say really quick and dirty. We can just let's do it properly. Say var directory equals path.getDirectory of the log path. So get the folder where the log path is in and ensure that the folder exists. And you could do that, to be honest, we'll do that in the constructor. So you're not redoing it for every single log. And you don't need to check if the directory exists because the create directory, if it does already exist, simply ignores it and does nothing anyway. So move that into the one-time spin up to create the directory. And now in the logger here, you can just do var file stream equals new text writer new or rather file dot open write and the log path. And I think you can cast that from file stream, or in fact we might want to, that might be okay to write to. No, so we want to do a new, it's a stream writer, I believe. This keyboard. There we go. So now we should have write line. So now you could write the message, and you could do more. You could write the date, the time, anything else. So writes the message to the end of the file. And in fact, you would also, obviously this is not thread safe, you'd lock this and you'd do other things. We're not really interested in logging specifically. This is just a point for a demo to give you the idea of what we're doing. This should also be file stream.seek. Got to get the base stream.seek. There we go. And you want to be at the end of the file. So we're writing to the end. Write the new line. So that now is a file log we've created. Fairly simple, but this is two real world things, and this is a common, very common use of interfaces to create a console logger and a file logger. So now the consumer here doesn't change, but your application at the top level, which would typically be this thing here we're faking right now, we just change at the top application layer, and now we want to use a file logger instead. And you'll see then that the requirement to specify a log path now is passed up to the top level application, which is fine. So if I just set this to say D drive some log test.txt, and that's it. Now we return that logger. If we run this, we should also see that now there's no console output, it's just said hello world. But if we now open our D drive, you can see we've got some log, and we've now got test, and inside it we've got say something. So if we run it again, we'd have two lines. And you can see there now. So we now have this log, which I'll now get rid of. So you can see there we've just quickly made an interface. I haven't described too much about the interface itself yet, but what you can see already is, firstly, they're created very similar to classes. Secondly, classes are what implement the interface. And thirdly, then, any class that implements that interface can be converted to that specific interface. So it allows swapping in and out of specific classes without changing the underlying code that needs to consume those interfaces. So the benefits here are, if you think about, say you have a requirement in your code, and it's a specific part of your code. So in this case, the part that just wants to log things. You want to put logic inside your code that says, if it's a certain day of the week I want to log, and if it's another day of the week I don't want to log anything. But the way you usually write code is in small chunks. So you'd want to write, say, a logger that can log to the console for debugging, and then a logger that can write to files for more, say, release mode, where you can then send the log files off. And those two behaviors are different, but ultimately, once you've created a console logger, you don't really want to recreate that for every project you ever do. And you also don't want to hard tie that into your code. You want it to be a thing on its own. It's a self-contained thing that can exist. So logging to the console and writing the way you want can be its own little module. And keeping code small and in chunks like that is very good practice. So you can unit test the console logger, then you can wrap it up, you can pass it around, and it's got one purpose in life, and that's to log messages to the console. Similarly with the file logger. But then when you build your real application, the thing that exists in the real world, and you want to sell and distribute and do something, it's not going to be as generic as just logging to the console and doing these individual chunks of code. That's where your application grabs all these different blocks, pieces them together into what makes your application what it is. And those bits of logic then exist in your top level application, but you want the logic to only be specific to your application. You don't want your application to also have to then write, console loggers and file loggers and generic reusable blocks of code. So with that kind of long-winded statement there, what I'm trying to get to the point of is you typically want to keep your code in chunks and in blocks. And then when you consume something, you want to do something, you don't want to code against a hard defined class. You don't want to code against a console logger and lock your application into only ever being able to log to a console without physically going through all of your code and changing all of that. So instead, what you should do, and what you typically do, is you write code against interfaces, not hard implementations. And then that allows the top level application that defines these things to simply swap those modules out without changing one line of underlying code. So that's kind of where the interfaces really come into their own. And in this example, I know it's basic, but that's sort of the point. So I just wanted to get that kind of message clear first, that the point of an interface is that you can swap out the real implementations without changing underlying code. So let's just carry on and look a bit more at this. So the other things we can do with the interfaces is to, say, put properties on there. So what we could do is add, say, a log level to the logger. And one could be, say, verbose, which is everything. Then debug would be the next one up, say. And then critical, which would be only the most important things. And that's not, we're not really bothered about the specific thing here. We're just showing the interface being able to have a property on. So now if we make a property called log level that is of type log level, and you can get and set it, defines the log level. In our implementations now, we'll have to add that. So if we just do control dot, it will add the log level. Change that to just normal get and set. Do the same for this one. We can wrap these up, make this a bit neater. Public properties. Defines the log output level. So we can copy that, same thing. And you could make a base logger here that these both implement if you wanted, if you start getting a lot of similar things, but you don't generally do that. You generally find that they're different enough that you don't typically have that much repeating code. Logs the message to the console. That's cleaned up, commented, there we go. So now we have a log level. What we'd normally do is, firstly, let's change this, say, for now to a new console logger. Let's keep it easy. And we'll also change the log level, now that property that's available to us, to only output when it's in debug or higher. So the way you typically log is if you set a log level to only output debug messages or higher, then verbose will be ignored. If you set it to say only log critical messages, then these ones will be ignored. So the check you do inside your logger, that's not constructor. That's probably, we haven't got a constructor here. So in here, you simply say if, and then we'd also have to pass in. So this now would need a log level, and we can set a default value in the interface as well. So we'll set this up to verbose to log everything by default. The level of the message or the log level of the message. So each message is defined as being a certain importance, a certain level, and the overall logger will only output messages that are above this log level. So that's how it typically works. So now these need the log level, and we copy and paste that into both. Now all we do is simply say if level is greater than log level that's passed in, then we log. So if this message is important enough, log it. And do the same for this. So if level is greater than log level, then we log. So now if we go to our logger here, we've got the logger, and we try to log something, by default now it will be verbose, and then we could also change it to say debug by just now setting the output there. Because we've set this to debug, what should happen now is when we run, this should have actually logged that one because it's debug. Oh, sorry, we've done greater than. It should be greater than or equals. So now if we run it and we correct that code, you should see just the debug output, which you see there. And this one being verbose is ignored because of this log level. So now this responsibility to define the log level is again passed to the application, the specific application, not inside the consuming code itself. So it moves the responsibility up to the top level application like it should be. So if we just change that back to verbose, you should see both of them being logged. And there you go. So that's another thing you can add to an interface, forcing a property. So again, whatever properties you need is irrelevant. This is just an example. You can do an indexer. Now an indexer is when you have an array. So if you have var a equals new string array, say, and you want to get a specific element from that array, you do, an indexer like that to get a certain element. So this is an indexer. You can define those on interfaces as well by basically saying something like return type of string, pass in an array integer value, and then return something. And it's only gettable, not settable. So you could define it like that, or you could do settable by including both. And then basically if that's now there, you could see here the consumer could do var a equals logger and pass in a number and in theory get something back. And you just define that behavior. But it's a rare case, and I never really use indexers, like custom indexers. So I'm not going to bother adding one to this because it kind of makes no sense, but you can do that. And then the last thing you can add is an event. So we just make an event with an action of string and a log level. What we'll do is say on log message, and we'll define that the event fired if a message is about to be logged, so that we could hook in and listen to these events. And again, now you'll find that the loggers need to implement that. So control dot, and it's added it somewhere. Let's put it inside there. So now we'd have public events. That would be equals message level, and do nothing with it by default. The event that's fired when a message is about to be logged. Copy that to the file logger, public properties, public events. There we go. So now we have an event we should fire if we're going to log. So now here you'd have sort of this, and you just say here inform listeners on log message level, and copy that. And what you can see here as well is, if you look at this logic in this instance, these loggers are identical with the exception of the final stage of physically writing the log. So what you might find is that you want to make specific raw loggers that just explicitly write to certain areas. Then you might want to make a parent class that handles things like including log levels and stuff like that, so that this logic is shared with a higher up class that consumes a specific type. But again, that's beyond the point of this kind of explanation. This is just giving you the example of what interfaces are for. So now if we were to go back to the consumer, this consumer now, regardless of the logger, could hook into when a message is fired and say, get the message, the level, and for now just write it back to console. We listen to a message about to be logged, and that could be space there, then message and level, say, just to output something to show we've kind of listened to the message. And now that should be fired for us. Oops, spelled listen wrong. And there you see no. So now we've listened to a message about to be logged, and then the specific logger has done its job. And again, we could change this now to a file logger, and it makes no difference. We'll still listen. Our consuming code will never have to change a single line. So that's all there is to interfaces in terms of consuming them and using them. So you define them like this. You can simply do a public interface logger, and everything in here will be public. And you define properties, events, indexes if you want, and methods. And then this interface can be implemented by a class. And to implement it, you simply do the colon and then the interface. And now you have to honor those specific things inside of the interface. That allows us to do things like, say, I logger equals, and you could explicitly cast a class if you wanted to, and force it to have, now this console logger that we know is now just defined as an I logger, so it allows you to cast. You could also do, var that way and do an explicit cast like that. So there's many ways, but ultimately what it means now is the console logger will implement this interface, so it can be cast down to this interface. It also means that when you're then sharing your code, say you've written this console logger in a higher up class in your code, a higher up level, but you want it to be passed down to a lower level that only knows about the iLogger, you can cast it down and pass it in. And that's, again, another benefit. So you want to do you really want to code against interfaces as much as you can inside your consuming code, so that it's not hard tied to a specific implementation of that code. It simply has to know that there's a logger and it can log a message, but it doesn't at that point need to know anything else about it. And it gives then your application the ability to swap and change these blocks of code at will. And like I said, that's really all there is to interfaces. The only other thing, a few points I'll mention is, one, unlike a class, say this console logger wanted to implement the file logger, and you can't then have two classes. I know this is going to fail because we haven't provided information, but the point is, if you had a class, you can't then do, say, file logger 2. You can't implement multiple classes. That's something in C# you can't do. However, what you can do, say we have two interfaces. We have another public interface, another interface, being really thoughtful here, and that just has void do something, as we started with. Your console logger can now explicitly implement two interfaces, and we just add the interface there to do something, which we don't do anything, ironically. And then your logger, say we have var iLogger equals iLogger of, or rather, let's say console logger equals new console logger. You could say console as iLogger, and you can cast the console logger, I'm sure you know where I'm going with this by now, to an iLogger, but you can also cast it to a console as something. What did we call the interface? Another interface. So you can cast it to that interface as well. And that's perfectly valid. And now you could do console as something dot do something. So you can cast your classes down to any interface they implement and then pass in, say a certain part of your code only knows about this specific thing, you can pass it in. It also means that your class can serve multiple purposes. It can implement multiple interfaces to serve specific portions of the code's needs without having to be one massive interface. So that's really useful. And then similarly, if I just bring back that interface, interfaces can implement other interfaces. So another interface could also effectively consume the iLogger and do something to it. So now if it was to be cast to another interface from the console logger, if that implements that, which it actually doesn't, so that would fail, but still. Oh no, we do. We've implemented it there. You wouldn't typically have to do the two because this implements that anyway, so you could just remove that. Then here now, your the another interface has do something, and it also has all the log messages. So in short there, interfaces can implement other interfaces as well. And I think that's really the only thing with interfaces, the only real use case and example of how they work and what they do. So you'll see interfaces used in all the code we do in these videos, all the Facetto, Word, and all the other projects, and especially in dependency injection and things like that. And you can really see now all they are as contracts, definitions of what classes should implement, with the purpose of then allowing code that's lower in the stack that is unaware of specific implementations can still consume and use those classes and and call the functions they need on them. So a lot of people seem to get confused about interfaces, but really it's a fact of just don't overthink them. They are really simple. They simply say this class, if it wants to implement this interface and be castable down to an interface, has to honor and have these specific pieces of information in. And that's basically so that when you try to cast one object to another from a class to an interface, C# knows at compile time if that's possible, instead of simply allowing it to try and fail. So it's all like a reassurance, if you will, to make sure your code isn't going to fail a cast. And then it also allows the things that want to, say, make use of interface-specific methods or properties rightly don't need to be aware of the real implementations. The way something's achieved shouldn't have to be a concern of the part of code that wants to consume that. So if I want to write a log, I want to say I need to log this piece of information. I'm a little module in code, and I want to write this piece of information to a log. I shouldn't have to be concerned about how that happens, where that log goes to, and what's done. That concern really is the application's concern. So the thing constructing the whole application and deciding where it wants the logs going. But the point of saying you want to log something, that piece of information is the interface. We want to log something, so that's all we should have to say, is ilogger.log message. But then in order to define where that goes and how that works is then the responsibility of, one, the application to say, right, I want to log it to a file. And then two, the specific file logger then is responsible for that exact task. So it makes the responsibilities of those classes and those chunks of code very modular. So the file logger needs to log to a file, but it doesn't need to be concerned about who's using it. The thing that wants to log needs to know that it can log and say, this is the message I want logging, but it doesn't care about where it goes from that point on. And the application can bring all these pieces together and all these modules together in any combination they like and easily swap chunks out. So that's all there is to interfaces. I feel like I've kind of not really explained them that well, to be honest, but let me know what you think. Again, I find it hard sometimes to explain really basic concepts because they're just I just know them, and trying to verbalize why they're important is a bit difficult. But again, as always, any questions, just leave them in the video and I'll get back to you. And hopefully you've learned something from this one, and let me know what you think.